Welcome guys to my YouTube channel. Today I will share top most expected question of compiler design. Now let's start. Question 1 is which of the following is correct statement? For this question I will take this diagram. For unambiguous grammar, it will ask every LL1 CFG is SLR1. For LL1, these are the LL1 CFG LL1 grammar, and these are the SLR grammar. It will ask every LL1 CFG is SLR1. Not every LL1 is SLR1 because this portion is not in SLR. So this is wrong. Now second, every SLR1 is LL1. Every SLR is LL1. No, this is also wrong because this portion is not in LL1. So this is also wrong. Every LR1 CFG is LL1. This is LR1 and this is LL1. You have every LR. No, this is not every LR is LL1. So correct answer is none of these. Now next question is, consider the following statements. Operator grammar can have two consecutive non-terminals. Operator grammar does not have two consecutive non-terminals, and epsilon production is also does not have. And left recursive grammar cause infinite loop in recursive descent parser. Yes, this is true because left recursive grammar cause infinite loop in recursive descent parser. And ambiguous grammar can be LL1. No, this is wrong. Ambiguous grammar cannot be LL1. So how many statements are incorrect? First one is this and third. So mm, mm, first and third are incorrect. So two statement is incorrect. Now next one is, consider the grammar. These are the grammar. Which of the following is true? The grammar is ambiguous. So no, this is not ambiguous grammar. The grammar is LL1 is in LL1. For LL1 we check by this method. First we calculate of first of yes dash, first of yes dash, A, B and has. This is has. When we put yes of epsilon, then we get has, and A, B from yes tends to yes produce A and B, and A produce A and epsilon. So A and B and has from here. So first of yes dash AB has here, and first of yes is AB. A, when we put A is epsilon, then we get B, then B, A, B and epsilon. First of A we will get A and epsilon. First of B, B and epsilon, and we will get follow of yes has, and follow of A, B comma has, and follow of B has. Then after calculating this, I put in this table. These are the terminal AB, has and dollar, and then these are the non-terminals. Then it's production. If first go A, I will put here. On B, I will put here. If if you put on follow, then we put epsilon. Production epsilon for follow of the production. So in this way I solve this question. Now next one is, a shift reduce parser carries out the action specified within braces. These are the production and these are the output will be produced. So what is the translation of this? Using the syntax direct translation scheme described by the following rules. So for this translation, what we will print, what we will output produce through print statement. So by this translation we will create syntax tree. So I will create in this way, mm, x and w and sz, and then this, and left side is its print output statement. So it will print from bottom, print 2 and then print 3 and then 1 and then 3 and then 1. So 2 3 1 3 1. So in this way I solve this question. Now next one is, consider the following grammar. Which of the following is true? The grammar is LL1 follow of A intersection first of A is equal to null set. So for LL1 we will first calculate first and follow of these element, non-terminal element. Follow of yes is dollar and for first of yes is A, and follow of A is equal B, and follow of B is equal to null, because follow of B, there is no B in right side. So B follow of B is null. So after calculating this, I will put in this table. There is terminal and these are the non-terminal, and put this production, and every every box have single production, so it is LL1. So it is LL1, and for and the grammar is LL1 and follow of A intersection follow of first of A null set. This is also true. Follow of A is null. Follow of A and first of A intersection there is no common, so it produces null set. So both A and B are correct for this question. Now next one is, consider the following grammar. Production E plus T and T production T cross F and F. So star is having higher precedence than plus. This is true. Plus is having higher precedence than stars. Only option A is true for this question, because T star is in bottom, so star is having higher precedence. Now next question is, match the description of the several parts of classic of this is for matching. A part of compiler that is responsible for recognizing syntax is parser. For syntax recognizer we will use parser. A part of compiler that takes an input as a stream of character and produce a stream of words along with syntax. So for this we will use scanner for scanning the stream of character and convert into tokens, stream of words. A part of compiler understand the meaning variables. This is understand the meaning in semantic analysis phase. So for this question, first have third, A with third, this, and B have fourth, and C has third, second, and D first. So for this question 1 is correct. Option A is correct for this question. Now next one is, the number of tokens in the following C statement is so for number of tokens we can calculate first printf 1, this small bracket 2, and this inverted comma have count 1, 3 and 4 and 5 and 6 and 7 and 8, 9, 10. There is total 10 tokens for this question. Now next one is question 9. For the give grammar below, a partial LL1 parsing table is also presented along with grammar entries that need to be filled or indicated. So it is this is the table, and this one is missing and this one is missing. So you will think, so we will find missing statement in what production is put here at missing statement. So yes, at first, yes, at A production it will gives yes production A capital A, B capital B. This production is placed here because first of yes is A and first of B E of yes uh, and first of yes also B. So this production is placed here. So after placing this production, we will calculate first of A and then follow of A and follow of B. So after placing this, we will calculate first of A is AB epsilon and follow of A is B and A. So AB and follow of B is follow of yes is dollar. So dollar is here, the dollar there is no dollar, and this is wrong. These are the wrong. You can also check. So for this question is option A is correct. Now next one. Question 10. Consider the following code segment in a compiler. The code is segmented. Basically, it converts in direct acyclic graph. It will ask for number of nodes in direct acyclic graph. For DAG, we will draw first. We will take B plus C. Here B plus C. It will goes to A. So here A and D also, because D have also B plus C. So after that, its sum goes to E plus 1, A plus 1, D plus 1. So plus 1, it will gives E and F, and then after E plus F goes to G. So in this way I draw the deck. So in this way I solve this question. Now next one is question 11. The grammar yes, A S A, B S C. So it will ask, this is LL1 but not LR, LR but not LR1, both LL1 and LR1. This is my mistake. This is LL1. So first we check LL1. If this grammar is LL1, then no need to check LR, because every LL1 should definitely LR grammar. So first we check LL1. So for LL1, we will calculate first of yes ABC. There is no need of follow because does not go epsilon. There is no epsilon production, so we do not calculate follow. So it is it's unique. First first of yes, all are unique. No no common element found. So it is LL1, therefore it is also LR. So it is both LL1 and LR also. In this way I solve this question. Now next one is question 12. Match the following: regular expression, lexical analysis, push down automata, syntax analysis, data flow analysis. data flow analysis, code optimization, register allocation, code generation. So for this question is option B is correct for this question. Now next one is question 13. Given the following expression grammar, A production E cross F and F plus C and F. So it will ask which one has higher precedence. Minus has higher precedence because it is on bottom. So minus has higher precedence than star. So in this way I solve this. Now next one is question 14. Which grammar rule violate the requirement of the grammar A, B, C are variable and A, B, C are terminal? This is asked for operator grammar. So operator grammar had two limitation. First, both consecutive non both if mm, if two consecutive non-terminal, then those grammar is not operator grammar, and also null production is also does not have null production in operator grammar. So 1 and 4 is make violate the rule of operator grammar. So for this question 1 and 4 only is correct. So option D is correct for this question. Now next one is question 15. Which of the following production eliminate left recursion in the production given below? Yes, yes, production AA and B. It says that to remove the left recursion, because to remove the left recursion, this A goes on left production, so it will ask for remove this left recursion. So these are the grammar. So for this question I will solve in this way. These are the grammar. First, I eliminating the indirect left recursion. This yes is indirect left recursion. So for removing this, first we put the value of this A, capital A and B at the place of yes. So we will get this production. Now we will first assume this right side element uh, is equal to another variable like alpha is equal to C and AD, and beta is equal to BD, and this is only terminal, so it will another variable, and it will terminal with non-terminal, so it will take in another variable. So now grammar after removing left recursion. So for removing removing, first we put yes A and B, and then A put A dash and B dash, which one is terminal, BD and A dash, this next step production, and then A dash goes to C, this term, this right term, C A dash and AD A dash and epsilon. There is mistake, here is A dash, here is A dash. So in this way I solve this question, I removing the left recursion. Now next one is which is true about SR and RR conflict. If there is no SR conflict in CLR, then definitely there will be no SR conflict in LLR. This is true. If SR if no SR conflict in SLR, then there is no SR conflict in LLR. RR conflict might occur if look ahead for final item reduce moves is same. This is also correct because RR conflict might be occurred, and known that CLR1 has no RR conflict, still no RR conflict might occur in LLR. Yes, if CLR has no RR conflict, but there is chances of RR conflict in LALR. This is also correct. All of the above are true for this question. Now next one is question 17. Consider the syntax direct translation associated sentence this using the SDTL. Uh, it will basically ask for draw the past the for this translation. So for this translation I will draw in this way: E star, and then E bracket, and then E bracket small bracket production, and then ID put A and B. So in this way I solve. Now next one is question 18. Which one of the following is true? The LLR parser for a grammar G cannot have reduce conflict if the LR parser for G does not have reduce conflict. This is false, because if LLR parser of grammar G cannot have reduced if the LR parser for G does not have RR conflict. This is false. If RR conflict have not RR conflict, then in LALR may be RR conflict. The symbol table is assessed only during the lexical analysis phase. No, the symbol table assessed all the phases of the compiler. Data flow analysis is necessary for runtime memory management. This is also wrong. Data flow analysis basically for code optimization and code generation, and also in runtime memory management. LR1 parsing is sufficient for DCFL. This is true. LR1 parsing is sufficient for DCFL. This is true. Option D is correct for this question. LR1 parsing is sufficient for deterministic CFL, DCFL. So in this way I solve this question. Now next one is question 19. Consider the following augmented grammar. There is a terminal and these are the production. Let I not closer s dash production dot s, the number of items in go to I not to production to next step through this element. So for this question I will solve through this way. First I will draw the s dot s production, and then transition from this terminal, and then we will get this I1 production, and then again transition from this terminals I will get this. So total number of element in this production I will get 8 elements. So for this question is 3 4 4a 3 3 6 8 element. So total 8 element. Option A is correct for this question. Now next one is question 20. Consider the following grammar: S production A as B, and D and B production B, the number of reduction steps it will ask for the accepting this string. So for this question I will solve in this way. First I will draw the I will write the string, and then write the production yes production D. So this is the D. It will convert into yes, because yes production D produce this D. So first reduce, and then B production B is used for B production. So second reduce ESB, I will get ESB, and then ESB ASB taken as yes. So it is third production yes through this production reduce, and then again B production B. So we will again reduce, and in this way I will get starting symbol. Total 7 step takes by through using this production. In this way I solve this question. Now next one is you also make practice so that you can better understand. Now next one is A bottom-up parser generate rightmost derivative in reverse. This is correct for bottom-up parser work on rightmost derivative in reverse, not leftmost derivative in reverse, yeah, or leftmost derivation or rightmost derivation. It is work on rightmost derivation in reverse. Now next one is consider the grammar with the following translation is the start symbol and past it will ask for compute e dot value for the root of the past for the following expression. For this question I will solve in this way. First I will draw the tree according to this expression. So in this way I draw the tree. First I will go E1 has T production and then AND production and then AND and then has, then I will calculate total value 160. In this way I solve this one. 160 option C is correct for this question. In this way I solve this question. Now next one is question 23. Consider the following. These are the production. Let the number of state in SLR, LR1, LLR parser for the grammar be N1, N2 and N3 respectively. The following relation holds good. We know that in LR, LR1, SLR1, LR0, LR0, SLR1, LLR1 equal number of states, but in CLR or LR have greater than is equal to n state, 2 power of n state. So LR1 and 2 has greater state than N1 and N3. So N1 is equal to N3 but less than N2. So for this question is option B is correct for this one, for this question. In this way I solve all these questions. For later update please follow, comment and subscribe my channel. Thank you.